Hi, everyone.
Hello, everyone.
I think like a lot of existential questions, we might not actually be able to answer this one. Just ask it over and over and over again. The second part, doesn't matter. But why networks halt? I think that's something that we can definitely get to the bottom of, right?
Sure.
Okay.
Let's do it.
So I guess first off, when we talk why networks halt, what do we mean when we say a network halts? What's the implication for applications built on the network and for end users?
Yeah, that's a great first question. So when we say that a network halts, basically we mean it stops finalizing new blocks, new ledgers. So transactions that are submitted are not processed anymore. They don't make it to the chain stops growing, and all the applications that actually use the blockchain, they also stop. So, we've seen that once with Stellar, I think in 2019, where applications like wallets, Vibrant, were just put into maintenance mode because they just couldn't make progress on the blockchain anymore. Now, one funny thing is that this doesn't mean that all trading activity related to the chain stops. And we've seen, for example, sometimes blockchains halt, but the price of their native token doesn't really move, it's still traded. And that's because this trading happens often on exchanges outside, like Coinbase, for example. Can you guys hear me? Okay. Yeah, but still, so everything that uses that depends on the chain stops, and it's pretty bad, I think.
Right, so those places where trading activity continues, though, they're in some sort of, walled garden, right? They're not actually transacting on the chain because, by definition, when actually transactions aren't being pushed to the chain, any on-chain activity halts, right? There's no on-chain activity.
Yeah, so I mean, when you trade, let's say XLM on Coinbase, you're not actually using the Stellar network. You're just moving stuff around in the database owned by Coinbase. And so that still continues to work.
So I think that, understanding that experience from a user point of view or an app builder point of view, what that actually means is something we can get to later. First, I kind of want to drill down into why it happens in the first place. So the first question here of the topic, of the title, right? Why do network halts happen in the first place?
Yeah, so I think that there's many reasons, but I think there's four main reasons that stand out to me. So the first one is what's called non-determinism. So sometimes there's bugs that cause non-determinism in execution, and that can cause a chain split and a subsequent halt. So that's the first one. Then the second one that we've seen happen fairly often is just luckily not on Stellar, but is that the chain gets just overloaded. There's just too many transactions coming in, and nodes run out of memory or some other resource, and everything breaks down. Then we have a third reason that we've seen happen on the outage that happened on Stellar in 2019, which is that there were just not enough validators online validating transactions, and so there was no quorum to be found on the network, and everything stopped. And then finally, as we've seen actually very recently, as recently as last week, we've got hacks, and then that happens on Binance last week. And then they just halted the whole chain just to sort out the mess, undo the hack, and restart it.
Okay, so four different reasons.
Which
are essentially non-determinism, resource exhaustion, right? Poor validator availability, essentially, and an organized action to essentially correct non-desirable on-chain state. Those are the four reasons, right?
Yeah, so they're not the only reasons, but they're the four reasons that kind of are most common, I think, and stand out to me.
Let's look at each of those.
Sure.
Okay. So I guess we can go in the order that you just said them, right? Non-determinism. Can you tell me what that is, why it happens, and why it makes a network halt?
Yeah, that's an interesting one. So as you probably know, so most blockchains, they use what's called a consensus protocol to agree on what is the next block that's going to be executed. So a block is just a list of transactions to execute. But the thing is that we we not only care about what transactions are going to be executed, but we also care about what state this is going to produce, right? Who owns how much of each token, for example. But the thing is that mostly for performance reasons, the state is not included in the block. And so that we don't have to send it over the network, that would be expensive. Instead, we just send a list of transactions. But so now the idea is that all the validators, they are going to execute those transactions exactly in the same way. And so this will bring them all in the same state. And that's what's called determinism. So the state produced by a block is determined, or should be determined, by the list of transactions that we execute.
Right, so you start with the same state, and if you apply the same set of transactions, then every state should be the same across all validators.
That's right.
Right. And so if that breaks down, that's non-determinism.
Yes.
Are there examples of when that's actually caused a blockchain halt?
Yeah, there are some examples. So in 2021, for example, this caused a blockchain halt on Avalanche. This year, I think it caused a blockchain halt on Solana. And also in 2021, there was an incident on Stellar, which didn't, strictly speaking, cause a halt, but caused some problems in the network, and this was also a non-deterministic execution problem.
Interesting. And the Solana's halted set a lot, right? Is non-determinate? Is that caused by many of these, or is non-determinism like a principal reason that sort of plagues Solana?
No, so that I know of, it happened once on Solana, and the other outages it was different issues, I think. But yeah, you're right that Solana is kind of notorious for halting fairly frequently. I think it halted 11 times right now at the moment since it started.
11 times.
Yeah. And, yeah.
Ouch. Okay, non-determinism. More to say on that, or should we move on to resource exhaustion?
Yeah. So resource exhaustion. That one is maybe a little easier to understand, right? If you just send in more transactions than the network can handle, this kind of pushes the system to its limits into some areas that were not often very well tested, or where the system is not designed to operate in, and sometimes the unexpected happens and things break down, the system goes down. And that, I think, often happened on Solana. I don't think it ever happened on Stellar.
Like what can cause? I mean, there must be mechanisms to prevent like that sort of resource depletion or resource exhaustion from happening beyond just like hardware with high specs. Like there must be throttles, right, to prevent that from happening. What are they, and why don't they work at times?
Yeah, great question. So the first line of defense, I think, against this is a proper mechanism to set transaction fees and adjust incentives so that people don't submit too many transactions to the network. And so the most common way to do that is to have what's called a fee market. Right? So on Stellar, for example, once the blocks start being full, so blocks have a fixed size, and once there's more transactions that can fit in a block, work goes into what's called surge pricing mode, and now people have to bid to be included in the block, and transaction fees increase as a result. And so less people send transactions because it becomes too expensive, and this kind of self-regulates. Right? This is also what happens on Ethereum. Now, one problem that with Solana is that there was no there was no fee market. And so it was just really cheap all the time, submit as many transactions as you wanted. And so I think
the fees were flat, no matter how much activity there was.
Yeah.
There was never an increase there was no surge price. No.
I think this was the case, yeah. And so the issue is that some popular projects launched like new NFTs or something like that, and then everybody was trying to front run everybody else to buy the NFT first. This caused a huge spike of traffic, and the network melted.
Yeah, I mean, it's interesting because obviously keeping fees low is something that is super important for Stellar. It's part of the mental model as part of the mission. It's something that has come up. I've already heard it like 4 times today. But there is a necessity for fees as like to prevent resource exhaustion, to make it so that like the network doesn't get overwhelmed, so that it can continue to work. There's like a balancing act, right?
That's right. Yeah, and I guess it's not easy to find the right balance, for sure. So
What was number 3? Validator availability. Poor validator availability. What's that? Why does it cause a network to halt?
yeah, I think I mean I included that one. Was mostly this is what happened on Stellar. I think in 2019, when this was I think the only time where Stellar really halted since Stellar started using SCP, and so the problem here was that the monitoring tools I think that were used at the time were not accurate enough, and so many nodes were actually not participating in consensus, not validating, but this didn't raise an alarm, and so it got to the point where there were not enough validators anymore in the network, and if you remove just one of them, there wouldn't be a quorum available to vote for the next block and make the blockchain make progress. And so at that point, things were still working, but then one more validator was taken offline for maintenance, and so everything stopped.
Right. No, there was not enough visibility, right? And when they could have just done that maintenance at a different time, but they didn't know that it would cause a problem, that would cause a halt. And definitely, I mean, I could say that it was an interesting moment in one where like a lot of people came together in sort of a war room, ran validators, and it was a problem that was fixed pretty quickly. I mean, the network total halt was 67 minutes, which is about the time that you have to wait to feel like a Bitcoin transaction is finalized. So it was actually a pretty good fire drill, and I think part of what came out of it was like better response, but mostly, as you pointed out, like better monitoring, better tools. So like now there's all of these tools that validators can use for their own instance to like sort of monitor the network, to monitor quorum intersection, but also Stellar Beat, I see Peter Yan here, is like really evolved, and it has this meta network view. And so now like, you know, I think it's really interesting that it's not always easy to have a picture of what the network looks like unless you build out tooling that allows you to sort of see it. And with Stellar, it's unique because your validator sees its quorum set, and building an overall picture of the network is even more difficult and requires these workarounds that Stellar V came up with. But without that stuff, it's it's easier than you'd think to have like validators not be available when they need to be. I don't know.
Yeah, that's it's really great now. I think Stellar Beat is way more precise in the information that it's showing, and I think that's very useful to the Stellar community. I don't think this kind of problem will happen again.
I'm looking for wood to knock on. But yeah, I mean, I guess like proof of stake has some sort of slashing mechanisms for availability problems. Like there can be disincentives or a stick that people use to like ensure availability happens.
That's right.
But and that's sort of the goal, right? So in order for a blockchain to continue to function, you need some minimum viable availability of validators.
Yeah. So as you're saying, in some systems like Ethereum, if you run a validator and you stop participating in consensus for too long, you get slashed, you lose money, and so you have a strong incentive to keep up. But we don't have anything like that on Stellar.
Yeah, that's an interesting. You know, it comes up a lot because validator incentives come up a lot. Validator disincentives don't come up a lot, but you know, that is sort of like that disincentive is a reason for high availability. But like, I do feel like people that use the network and that validate the network do want the network to continue to move forward. And I guess we'll get to, does it matter if networks halt? But I think it's in their best interest. But it's interesting that like disincentives exist in other consensus protocols.
Yes. Yeah. I guess we're far from there on Stellar because we don't have incentives to start with, so at least not formalized ones. Yeah.
Okay, number 4 you said was, and you brought up the Binance halt the other day. This one's pretty interesting. It's basically halting on purpose to correct undesirable on-chain behavior, right?
Right. Yeah. So that made the news last week when there was a big hack on Binance, and I'm not sure about the details, but of how they were able to just halt the chain because it's supposed to be a distributed system, right? Maybe the whole community just came together and let's say, okay, let's stop validating. But so they halted the whole system until they were able to figure out what happened, revert the malicious transactions, and then restarted it again. And so we've seen also similar incidents on other chains like Ethereum, the famous DAO hack. And so there it didn't cause a blockchain halt because they were fairly lucky, actually. So
What do you mean by they were fairly lucky?
So what happened is that the hacker managed to extract funds from this DAO on Ethereum, but the funds were locked for a period of about 30 days, if I remember correctly. And this was one of the rules of the DAO, and the hacker wasn't able to go to subvert this rule. So they
had a 30-day window to try to figure out a solution.
Exactly.
Built into the contract itself.
Yeah. So they didn't panic, they didn't halt everything, they just said, okay, let's continue, we have 30 days to figure it out, and then they found a way to just, before those 30 days elapsed, inject some transactions that were crafted just to take this money away from the hacker and put it back where it belonged.
Right. Interesting. So in these examples where there's a halt, a sort of orchestrated halt, that implies orchestration. So validators are convening somewhere, and they're saying, all right, we have to stop this. Something's gone haywire. Everyone turn off your node. Unplug.
That's right. So this is commonly known as social consensus.
Social consensus.
Yeah. So this really hangs on the community getting together and making a informal decision. So on Ethereum, for example, it's fairly easy. Vitalik says, let's do it, and they do it, right? Usually.
Yeah, social consensus by fiat.
Right.
But okay, we went through these 4 reasons why networks halt. What about attacks? That's not a reason that they halt. Is there an attack vector that could cause a network to halt?
Yeah, for sure. I mean, the 4 reasons we went through are just like problems that happen even like without attacks. But if you have an attack, obviously it makes things way worse. And I think it's interesting that we've not seen that many attacks on blockchains that caused halts. But also, if I guess if you're a motivated attacker and you find that, I don't know, a vulnerability, you're also, maybe what's even better for you to do is to cause a chain split, which is even worse. I would say.
So a fork is
yeah.
distinct from a halt because instead of the network ceasing to process transactions, now there are, well, explain what happens in a fork. What's the difference? Which one's worse?
Yeah, I mean, I definitely say that the fork is worse because it enables stuff like double spending, right? So when there's a fork, there's basically 2 versions now of the ledger, or more than 2 that emerge. And then some parts of the network think that version A is the right one. Some other parts think that version B is the right one. And eventually it's resolved for A or B, but this means that if the network chooses to resolve it for A, and you spend some coins from B and you got some goods in exchange, then you still have those coins on A.
You're very lucky.
So you doubled your coins in some way.
That's non-investment advice.
That is not investment advice.
And yeah, so okay, so the implications of a fork are certainly like people can lose money or make money, but it sort of messes up the balance of value in the world.
Yes.
Versus just like having everybody stop and sit on their hands for a while.
Yeah, and Yeah, and I guess so. You have those two versions of the state, and it can also be really confusing for applications because applications assume that this never happens, and so they might corrupt their state or stuff like that.
Right, right, and I mean, I'm sure So Stellar in this sort of triangle of safety, liveness, fault tolerance, opts for safety over liveness.
Yes.
And I think the reason why is because of what you're saying, right? That it makes more sense, especially when there's real value issued on the network, for some sort of contention or issue for the network to stop, so that transactions don't keep happening in a way that actually creates or destroys value, so that there is no ability to double spend, right?
Yeah, and so maybe we can talk a little bit about what happened on Stellar in 2021, because there was in some sense a fork, but it didn't halt the network, and everything continued working properly because of this preference for safety. So the network detected that some validators were forking, and those validators, because of the way SCP is designed, immediately stopped. So there was no opportunity for a double spend or anything like that. And the rest of the network, which still contained the majority, or what's called a quorum in Stellar, was able to just continue as normal.
So SCP said there's a divergence here. The sort of validators that make the quorum will continue to go. Those that disagree, halt.
That's right. Yeah. So what happened is that there was a non-determinism bug. So this was the first reason we talked about. So some validators computed a state after the block that was different from the rest.
What was the difference?
Yeah, that's a great question. I think it just all hinged on a database upgrade that caused some fields in the database to be null by default when you rebuilt the database. And so nodes that rebuilt their database recently got this null value in this particular field, while nodes that didn't rebuild their database recently had a different value.
But also that basically meant nothing, right? It wasn't a null value, but it. Yeah. In other words, it wasn't like a disagreement over a transaction over like some sort of network setting. It was like a database basically put zero in as
That's right.
in. Yeah. Okay.
Yeah. So I don't think it had any meaningful or it wasn't maybe visible to applications, but for SCP, so what SCP does is that in the next block it includes a hash of the result of the operations in the previous block, and because of this null value, I think the hash didn't correspond, and then those nodes were able to agree on the next block. So
yeah, I guess now, I mean, there's a few minutes left, so like I kind of want to shift a bit to like, does it matter? So, this what we were just talking about was this very this non-determinism bug that made the Stellar partially halt. Although I guess in that situation, the network kept going. Validators that had a different view of the database just needed to upgrade it to rejoin, and then they could catch up. Right?
That's right.
But still, like Stellar is known for being quite stable, right? As we were saying, Solana's halted 11 times. I don't know how many times Binance Chain, for instance, has halted, but Stellar halted once in 2019 for 67 minutes, and it had this other issue where certain validators halted, but the network kept going. And I guess my question is, like, if you're trying to decide which network to build on, right? Like, is this a consideration? Do you think I'm going to build an application and I should build on a network that doesn't halt a bunch?
Yeah, I mean, to me, I think fairly important, because your application is just going to stop working whenever the network halts, right? And then I think there's also it's also kind of maybe a bad sign, because it might indicate that there's a lot of technical debt that has accumulated in the system, and that's going to have to be fixed at some point.
But like what? So are there advantages to choosing, but like networks that halt a lot? Do they, Solana halts, as we said, a lot, but it also has a pretty vital ecosystem of companies building on it and developers attracted to it. Like, why do you think that is?
Yeah, so I mean, some people say that it's okay for Solana to halt from time to time because they're prioritizing adding new features and growing over stability. And once they get the features they want, they'll I guess work towards solving their technical debt and become stable. So I think that's the idea with Solana.
So people accept the technical debt. They believe that they'll be able to create a stable network in the future, and they say, just give us features.
Right.
And are there more conservative views? Other chains that are, I imagine there are, that have like a very opposite view.
Yeah, I mean, and for sure, like if you look at Bitcoin or even Ethereum, I mean, I think a halt on Bitcoin or Ethereum would be unacceptable to the community. And so they're really at the other end of the spectrum. But that means that also change is very hard. Like it's famously difficult to change Bitcoin to introduce any new features. Right? So that's the flip side of the coin.
So if Solana's, fast changes, features over stability, and like Bitcoin's no new features, highly stable, like where's Stellar in the spectrum?
Yeah, and so I think historically Stellar has been in the stability camp, right? There's been only one halt as we've seen. But now we're introducing Sorbonne, right? So this is like a very big challenge, a very big change to the network. So maybe we are shifting the needle a little bit towards a little more risk, but maybe a little more reward with new features that are going to be useful.
Right. So there's a question: how will Sorbonne impact network stability? How's it gonna slot in? Right?
Yeah, exactly. Yeah. But I think the Sorbonne team has been doing a really great job there because the Sorbonne is really developed as mostly independent component where I don't think we're heavily modifying the existing code base. We're just adding a new component. And so the clear separation between those two will definitely help keep the system stable for sure.
Cool. Anyone have questions? You can just yell it too. I can repeat it.
Exhaustion. Knowing the fees are low on Stellar, why haven't we seen a denial of service attack essentially take down the network? Is that just because the transactions to date haven't reached the threshold? And if so, where is the threshold? How much would it cost to take it down?
Yeah, excellent question. So fees are really low on Stellar, that's true, but there is a fee market. I think for now, the one thing about Stellar is that it's one of the blockchains with the highest capacity around. I mean, real capacity, not advertised capacity, like Tomer said before. And so it's not been a problem so far, but if there was a huge influx of transactions, the fee market, the surge mode would kick in. Fee would increase, and hopefully this would disincentivize people from submitting too many transactions. That's the idea.
I mean, I will definitely say that as network activity has increased, the network has been in surge pricing mode more. So, if you went to early Stellar when the network, the actual capacity of the ledger is like a network setting that validators vote on, right? So it's currently configured at 1,000 operations per ledger. And if you looked back, 4 years ago, there was never contention. There was always under 1,000 operations per ledger. And now when there are big spikes, which are sometimes caused by, say, arbitrage bots, the fee market will kick in, fees will increase, but they only increase at the moments when they need to. So fees overall are low, but if you're building on Stellar and you just set the minimum fee like as your fee bid, you might find that you get priced out by surge pricing. So it is interesting to see when surge pricing kicks in, and it really is this very reactive throttle. So a massive attack would just become very expensive very, very quickly. But to answer your question of how expensive, it depends how much people are willing to bid, right? So the more that people are willing to bid to get a transaction onto the ledger, the higher fees will go. And so if there was an attempt to really push a bunch of junk, it would be contending with real transactions. And so it's impossible to say exactly what it would cost. All right. Any final questions? Are we good? Awesome. Thanks, Juliana.
Thanks, Justin.